Hello, everyone. We'll wait a few more minutes for other people to join. Please do add your name to the attendees here in the doc. I'll share this again in a bit when everybody's here. Hello, everyone that's joining. We're just giving a couple more minutes for other people to get online. And since I haven't heard anybody yet, can you all hear me? Just to make sure my...
Yes.
Yes.
Okay, great. Thank you for confirming. I didn't want to be here talking to nobody and not able to hear others.
we miss seeing you. Usually you're visual. Well, there we go. Yes. And I am remiss in not showing myself.
Yeah, I joined a couple minutes early, and I usually turn off my video while I'm, doing other things. Okay. So our main presenter this week was going to be, I believe, Anne-Marie from Talus. I've not seen them join yet. So we'll give a couple more minutes there. They did confirm yet this morning that they were going to be here. I don't think there's a way in Zoom to pin things, so I'm going to keep dropping this link in the chat for people that are joining. It has the meeting notes and a place to put yourself as an attendee. So while we're waiting for Anne-Marie or others on her team to join, something we haven't done in a while is do introductions for people that are newer to the group. If there's anybody that is joining for the newly joined in the last few months, that is on the call here, if you want to introduce yourself, that would be great.
I mean, I can start. Are you able to hear me?
Yeah, go ahead.
Yep. So I'm Lachlan Gunn. So I'm from Aalto University in Finland. So I'm a member of the Elastic project that I guess many people here are from. I think there are actually quite a few of us here in the call at the moment. So I've worked on kind of a lot of kind of platform security and especially things involving trusted execution environments for a few years, and especially about how to try to solve distributed systems problems with remote attestation, and try to apply this to things like consensus, to things like or machine learning or various other kinds of systems. But I won't bang on for too long in the roundtable here.
Great. Thank you. Welcome. Anyone else? Okay, I guess nobody else wants to go through intros. I did see that Anne-Marie has joined. I know, as you were saying, Lachlan, that you were also from the Elastic project. I'm not sure how many of you here as part of presenting this topic, but I think if you all are ready to go, I can go and hand it over. And I will, one last time here, I think because enough people have joined, paste a link in the chat here where people can see the agenda. It's very short this week, but also a place to put your name as an attendee. But Anne-Marie, nice to meet you, and I'll let you take it away if you want to give an introduction to yourself and the topic.
Yes. So sorry, I'm late because I had some issue to connect to the Zoom.
No worries, that happens a lot.
I'm Anne-Marie Praden from Thales, and I'm the lead of the task 3.3 of the Elastic project, where we work on the remote attestation. We need your help, in fact, for this work and for this task. What you want? You want me to present the Elastic project and the slide that I'm sent to you, or what you want?
Yes, that sounds great as an introduction to the topic, and then we can get into the discussion that you'd like to have.
Okay. So I sent to you some slides, so I will, I think it's possible to share. How I can share it? Sorry, but I'm not very share screen. Share, no. What's those?
So you sent 2 decks. If you're having trouble presenting, I could open one and share it. The longer deck, the overview deck?
I can't share screen, but I. Oh. So this one, share. Oh, So do you see the screen? No.
No, we see the screen.
You see the screen?
Yeah.
Okay. So.
But it's a wrong screen. It's not the slides. We are seeing the screen of Zoom.
Yeah, we see your browser. You shared your browser window.
Okay, so it's not the good sharing.
I'm gonna hide my video for a second so I'm not looking at an inception of myself.
That's a reflection. So
if you can share your the slide that I sent to you, it would be nice because I'm sorry, but
let me try to pull that up then. I do have this. And there. And just tell me as you want to advance.
Yes, okay. So this is the project. So I don't know if you want to go into the detail of the project itself or just in the remote attestation part.
I think some context on the project would be helpful, but I think this group will be most interested in the attestation aspects.
Yes. So for this overview of the project, so you can go to the next slide. So for the project, we have 13 partners, and it's a research project that will last 36 months. It starts 1 year ago, and you have the budget of this project. I don't think that it's very important for you. The next slide, please. So we have different partners, some academics, and some companies like Telefonica, Thales, Thales 6 or Thales DIS. We have Ultraviolet Consult also, and some academics like the Lund Universität, the Aalto, and we have also Ericsson on company, and the so the TUC, which is the Politico Kritis in Crete. So and Torino also, Politecnico di Torino. So so you have all the partners here, the 13 partners. So we can go to the next slide. So this Elastic project was for the CG communication network, containing some edge cloud computing, so to large use of the network. So, and we want to enhance the security inside 6G. So the next slide. The first challenge is the security of the lightweight and portable executable isolation. So we use for that also the confidential compute and some technology for the isolation. Efficient and secure serverless orchestration over heterogeneous continuum. So we want to have an orchestration on the cloud continuum, from the cloud from the core to the edge and to the far edge also, with the IoT device. We want a privacy-preserving multi-party confidential computing, and also portable and secure workload distribution and execution over the constrained far edge IoT device. So it's what I said. So it's really a cloud continuum. Next slide. So it's the mission. So it's kind of repetition, I guess. So the aim of Elastic is to enhance the efficiency and the security of the service orchestration in a highly distributed and heterogeneous context. So for a cloud continuum. Elastic will focus on combining some key technology from the modern cloud native ecosystem and to enhance the service of orchestration and the security over the 6G network. And for that, we have different challenges that we find in the next slide. So we have a part which work on the WebAssembly, and also the function as a service, serverless function as a service, the confidential computing, and the eBPF and XBP technologies. What we can say, so for the objective, so the next slide is the objective. I think we can go further. So we have a different pilots. So this is the next slide. So the first pilot is the IoT data fabric solution for hyperscale data processing in 6G timeframe. So for that, we will have eBPF for security vulnerability, the WebAssembly, and the function as a service security framework. And they use for this pilot also the remote attestation platform. After that, we have a second pilot for the IoT privacy preserving a confidential computing platform to migrate on-premise sensitive IT service to the cloud. So here we have we use a confidential computing and we want to migrate the service, the sensitive service to the cloud. So we use for that the confidential compute, the VM-based trust execution environment. We want to have a hardware abstraction for this remote for this TE. We have WASM containers and eBPF monitoring. And for that we use also some component like so the remote attestation and also a key broker service for this migration. So that's all for this slide. For these slides, we have other slides for the remote attestation where we can. So it's very high level slides because what we want is really to discuss with you on what you can bring to us on the need for the attestation and the remote attestation. So I have some slides. So if you can share the slides.
I think this is the what you're talking about.
Yeah, so it's so this the remote attestation is part of the work package 3 that works on the confidential compute, and we have a specific task for the remote attestation. In this task, we have different partners involved. So Thales DIS, Ericsson, Finland, Ultraviolet Consult, Alto University, and Lund University. So we have 5 partners for this task. So the remote attestation, and I think I will not. You are very aware of that, is a crucial security service to establish the trust between entities in a zero trust environment. So At this time, the remote attestation suffer a lack of interoperability, which is an obstacle of to mass deployment, and its use in a heterogeneous cloud continuum. So the objective of the task 3.3 is to develop and enhance a remote attestation mechanism for the trusted execution environment. And for this objective, the key focus area are the following. The first, to leverage the standardization effort as done by RATS, for example, for the compatibility and interoperability in the use of the different TE solutions. We want to strengthen the security and robustness with the use of root of trust and cryptographic mechanisms, and explore lightweight and efficient protocols that will be used in a distributed and heterogeneous system, where we can use a very large number of IoT devices. So we have to ensure that the attestation could be distributed in this kind of environment. It will result in the enhancement of the reliability, the scalability of the confidential computing for these infrastructures. And so the next slide. So we are working currently working on the state-of-the-art analysis for the remote attestation, and for this we need your help, because we want to explore all the projects that work on the confidential compute for the remote attestation. So I think that you are the expert on in this subject. So we explored implementations and different TE. So the AMD one, SCV, SMP, the Intel one, so more TDX than SGX. But for the remote attestation, the SGX remote attestation is used for the TDX, I guess. The Keystone and Covey. So these are the TE that we are exploring. But the TE is not sufficient. We have also implementation of this TE in different cloud platforms. And I guess that using a cloud platform, the remote attestation could differ. And it's, for example, Microsoft Azure, AWS, and Google Cloud Platform. Even if they use AMD or Intel or other technology, the implementation in their platform could differ. So we want to explore the different way of this, the different implementation of the remote attestation itself. How they combine, is it combined with the other VM? So you have a confidential compute, you have other VM, they combine or not, how this is done. And we have also open source project that have probably some remote attestation function. So how it is implemented in this open source project, and to see, so this state-of-the-art analysis will give us some information on how we can abstract the hardware and use a common implementation of the remote attestation. So after this SUTA, we will see how we can strengthen the security and the robustness of the attestation mechanism. We will develop efficient lightweight attestation protocols that could be used for example, the IoT device and all these little components, and define also the hardware abstraction layer for the WASM runtime inside the confidential compute. We want to ensure the interoperability and support large-scale deployment of this attestation process. So this is what the aim of this task. And for that, we need your help because we know that you have a large experience of this confidential compute and how the attestation is done in different confidential compute. That's what I can say on the project.
Okay, so I think we can dig in some on what you'd like to get from us as a group, but I think there's probably the questions that people have about the project and what you are intending to build. I'll start with one. I noticed that, like, with the WASM layer in there was mentioned a few different times. Here on this slide, it's mentioning it as in reference to a hardware abstraction layer. Is WASM mostly being used for portability so that you're not dependent on x86, or is there other WASM functionality that is critical here, like sandboxing and attesting to sandboxes, or what is your intent there?
So we will use WASM as for the interoperability first. So if there are some people from the Elastic project that want to give some answer to I see that we have Drasko or
yes. Okay, so Drasko is here. I'm involved also in CCC within LF, so most of the people probably know me. But I'm also involved in Elastic projects. So WebAssembly here is used for interoperability, but it's also very important for sandboxing. For example, Aalto University and Lahan, who just presented himself in the beginning of the meeting, they are working very much on the isolation procedures and the sandboxing mechanism, especially when it comes to WASM runtime, and also to the problems we had with trusted execution environments and migrations of TEs. But in general, that's our main goal. And then also one of the inspiration was an ARCS project that was hosted within CCC. So the idea was to have something very lightweight, like not even a full-blown OS running inside the TE, to give us some kind of abstraction layer on top of which, or to give us a minimal trusted compute base on top of which we can run the application. And as you saw within the project, the orchestration of functions is important topic. So we figured that actually those functions can be then compiled as WASM, small WASM modules, like super lightweight containers, and then thrown all over the Cloud Edge continuum to some TEs, and then executed confidentially within those enclaves, and that those enclaves actually should have a really minimal TCB thanks to the WASM runtime. So that was kind of initial motivation to combine WASM and of course, trusted execution environment.
Okay. Thank you. I don't know if this is in the order the hands went up. When I was presenting, I couldn't see them go up, but at least the order they're listed on my screen. Usama, you have another question?
Yeah. So thanks for the introduction to your project. So I would like to understand which attested TLS project you are proposing to use or are currently using. Can you say a bit on that?
Yeah, I think we
The
haven't.
open source. Yes. Okay.
Go on.
Lachlan? Yes.
Yeah, I was going to say, I think we haven't kind of fully settled on exactly which protocols are going to be in use at the moment. I can speak for the work that I've been doing. We've been we at Alta have been trying to work on things maybe at a slightly higher or lower level, depending on your perspective, so that then there can be, let's say, greater impact in terms of which applications it can be, which applications it can then be integrated into, so that you don't end up in the situation where, we've built some kind of fancy establishment thing that is tightly integrated to RATLS, but then isn't going to work with some other protocol. But I think Anne-Marie is working with perhaps things that are a little bit more kind of concrete and less off in the sky than what I do. So maybe you can say something more specific.
So we will. Sorry. Lachlan, you want me to give some more explanation?
No, that's fine. If what I said is correct,
okay.
that's fine. I just thought I had interrupted you, and I didn't want to.
No.
I didn't want to give this vague answer if you had something specific to say.
No.
So my understanding is what you are saying is you are currently using some type of RTLS. Is that what you said? Did I get that correctly? Or did you say that you are currently exploring that?
We're currently exploring that. I mean, I can.
Okay.
I can talk a bit about what I've been doing, and maybe that would make a bit of sense once once people have finished with their questions to Anne-Marie's slides. If that would help.
So just to maybe I would like to understand better the question. Did you ask about the protocols of attestation itself, or what was the question?
So my question was that not the attestation itself. So typically in confidential computing, you don't use attestation alone because that can result in relay attacks. And then also the problem there is that you have your claims, device level claims available to the adversaries if you use attestation only. So typically what you do is you compose it with some secure channel. TLS is one of those, and Google has recently proposed tested noise. So my question was regarding that, whether you use, let's say, a tested TLS, whether you use a tested noise, or
so we based. I understood now. So we based our work on a tested TLS that came, that we mostly picked up from RAT's spec from ITF, right? And we have an implementation of this to the partner called Ultraviolet.
RATS has no spec on attested TLS. So RATS works only with remote attestation. Are you talking about the draft which is in the TLS working group?
Yes.
Okay. So, and the one which is using intra-handshake attestation, or the one which is using post-handshake attestation?
Intra-handshake attestation. So this one is implemented, tested, and working within a partner's repository. So I pasted a Ultraviolet implementation of the hardware abstraction layer that we are using within the project. It's called Focus AI, and within you will find also the implementation of intra-handshake attested TLS that has been implemented and used across the various platforms. So AMD SCVSMP, Intel TDX, but also functional within the Google Cloud platform and Azure. So there has been a work recently to upgrade Cocos AI to work on over all those platforms. And one specificity of this hardware abstraction layer is also that it's working with multi-party computation, which is part of our project as well, and is able to emit I'd say, so we are using a TLS for various partners that are providing data to attest the VM and then safely upload data for the processing within TE.
Right. So can you be more specific on what exactly in the draft or which option exactly in the draft you're using? So within intra-handshake draft, there is an option of remote attestation only, and there is an option of remote attestation with PKI. So which one have you implemented? Can you be more specific on that?
I cannot, because I'm not really the engineer who's been implementing this, but I think it is the one with PKI.
So the reason I'm asking is that we have found some attacks on the proposal that was there, and the latest version even is worse than what it was in the version 8. So I will put a link in the chat, and I would like to talk more about it with whoever your engineer is in order to understand what exactly have you implemented maybe.
Sure.
Hello. Sorry.
Danko, you're here.
Yeah, sorry for
great.
Here's the engineer.
Yeah, sorry for interrupting. I wanted to just yeah. So we are using the option of a certificate with attestation. So yeah, we are sending the attestation. We have implemented the TLS extensions to send the attestation to the client who verifies then the attestation.
Right, but then in certificate verify message, you have no possibility of sending both proof of possessions. So how do you deal with that?
Sorry, what do you mean by proof of possession?
So you have two keys now, right? So you have one which is C assigned. So you said you are using PKI with remote attestation. You have one key which is from PKI world that is CA certified. You have one key which is generated ephemerally within the TEE. And the point is that how do you provide the proof of possession of both keys? So that's one problem that we have been working around for quite some time now. And I was wondering how do you do that? Because if you use TLS, that certificate verify message of is not extensible, right? So you can provide only with one key. And I wonder which one do you use? Do you use the one with PKI or do you use the one with remote attestation?
Okay. Yeah. So in our model, we use just in-RAM CVMs. Our agent generates the keys for TLS that will be used for TLS, and the agent inserts the hash of the public key into the remote attestation.
Right,
so,
but all of that is orthogonal to what I am asking. So
I think, somewhat for the sake of time, I wonder if this, we identified something that should be dug into with the team, and maybe some offline conversations. I wonder if we can move on down the line for questions.
Okay, sure.
Do you mind if we move on to someone?
Yeah, that's fine.
Okay. So the next on my screen is Fritz.
I have one question. It was already partially discussed a little bit with the TLS pieces, but during the presentation, you mentioned a little bit things like IoT and all across the stack. But can you say a little bit more about what your actual target environment's capabilities are? Because if you look at like different places on the stack, for example, I put in chat SPDM, which kind of discusses gathering evidence for a specific kind of range of devices, right? But then when you look at lower capability devices that may not even have asymmetric crypto capabilities, then of course some things like TLS or others won't apply, right? So maybe it helps to specify, at least informally for us here, what devices are you actually looking at? Are you really looking at most the data centers for these WebAssembly function as a service style deployments? Or are you also looking at lower end, like Blimey, Lachlan wrote a nice paper here last year on that, right? These edge cases, not edge applications, but edge cases for lower end devices that might need new standards or new things for attestation that haven't been discussed by companies.
So I might take this one. So we are looking at both actually in two different work packages. So one of the work packages is really, I mean, let's say most of the work is indeed looking at the problems with cloud center, data center deployment. So in the cloud, on sufficiently, powerful servers. But there is a work package that looks into the edge devices that can be embedded Linux gateways or even the microcontrollers. In that sense, my group is mostly interested in RISC-V architectures, and we've been looking at Keystone and the Cove architectures. But otherwise, here the ARM, CC, and others are good candidates also for analysis, and we will use those in use case 1 or the pilot 1 within that is led by Ericsson, that where we are practically applying this use case on smart manufacturing, and in this factory use case we have a lot of embedded devices, sensors, and some of the edge devices on which computation can be sent and executed over there on the factory floor. So both of types of devices are of interest in this research.
I'll yield to Yogesh in 1 second. I just want to state that I think it would. I think this forum can help you finding the right things and also answering some questions. But at least for me right now, it's not clear yet what challenges you actually face or see, because I mean, all of these companies, Google, Microsoft, etc., right? They're all working on making attestation usable and possible, and then we have all of the ARM folks bringing all of these standards, and all of the other folks bringing in these standards. So the forums are there, and I think many challenges are being addressed. So it's not clear to me right now what, at least on the data center side, open challenges you have. So happy to discuss if you have specific questions or see them. But Yogesh, I was holding you off too long. Go ahead already. You can. I will shut up now.
Fritz, I think I had two questions, and you precisely asked the same question which I had. What is from the presentation, I was not able to make out what their security goal is focusing on. Is it the endpoints on the edge or servers in the cloud? But I think that is, I think, already answered. Maybe defining two presentations or two clear separation would kind of help understand their overall security objectives on both sides. That's one comment. Now it is comment because the question has been answered, I suppose. The second question I had is because you're talking about the 6G and you're talking about core network as well. Is it tied to some kind of VNF security as well, because I didn't see the explicit reference? But are you trying to understand, or are you trying to address the security around the VNFs in this specific setting? This question to the presenters.
Yes. So in fact, it could be a VNF for the core network also. Yes. So in fact, it addresses any container that we a sensitive software that we need to be included in the confidential compute. So it could be a VNF for the core network of the CG network.
Okay, thanks. Thank you. Yeah.
Okay, so I think we got through at least the hands up for questions from the group, and we have about 10 minutes left before we need to wrap up. Are there specific questions you'd have for the group or next steps you'd like to take with engaging with this group to find answers?
So we wanted to know what is the CCC work on the remote attestation that you are currently addressing, and but also how we can abstract the hardware, and do you have something, some attestation procedure for this that abstract the hardware for the time being? Do you have something for our hardware abstraction layer? So you have also work on the different open source, and what kind of issue you encounter for the remote attestation, for example, in NARS and other open source. Do you have some something to give to us on that? And the last question is really the challenge and the barrier to get this unified remote attestation. And what you can share on that? What is the barrier and the challenge for this remote attestation, independent to the hardware, and if you have some really if you can share something on that. So that's.
Okay, I think that there was quite a bit in there. I think that you were asking. One bit that I'll pick out of it that stood out on the hardware abstraction. At least my take, and if anybody else has a different take, please speak up. Is that like general hardware abstraction for like the application and being able to run is not something the attestation group has looked deeply into. However, I will say that as a general pattern for the attestation aspect, in order to not be dependent on the attestation specifics of each technology, is the attestation verifier pattern that the IETF RATS specification has defined. We've seemed to have consolidated around that, and that allows you to send the attestation evidence to a verifier, either using a credential that you get using the passport model, or sent by the relying party in the background check model. That allows the relying parties to not have to deal with the specifics of the hardware platform, and instead the verifier is the one that abstracts that by returning a common format as a attestation result.
The attestation result with the ERR?
Attestation result, what was that?
Yeah.
With the
Yes, ER4.
ER4C and EAR.
ERR.
Yeah. That's correct. I think you're looking at the right document then. Yeah.
Yes. So the EIT for the evidence, and after that, so it's a way for you to abstract the hardware. In fact, it's abstracted inside the verifier itself. That's what you say. It's a verifier that is able to abstract this.
Yes. Yes, because the verifier would be able to take the the specific formats from as attestation evidence, and then return a common format in the form of a EAT or EAR token.
And the way to launch this attestation. So in fact, you have an application inside the confidential compute, and you want to launch an attestation. So there is a need to send some data, and also the so this function is really can be independent to the hardware. You can launch an attestation without knowing the hardware itself. For example, if the runtime want to launch an attestation,
Yes.
is it independent to the hardware?
If you're looking at, for example, the Linux, a Linux guest, a recent one, say 6.11, let's say, they implement the config.fs TSM ABI, which is a common standardized interface to the underlying attester. So you have the application that can just seed the nonce into the ABI and then get back whatever the attestation evidence is, right? TDX, AMD, CCA, whatever. Take that and send it to this verifier, one that Keith was talking about, which will absorb basically the complexity. So it's not the task of the application on the node, on the attester node, to understand the evidence, the possible
Yes.
It's the task of the verifier to absorb that complexity, get back a standardized view of the TE in the form of these are R4C claims, which are basic homogenized views of an idealized attester to a relying party that then can implement a policy based on this standardized claim set. That's one way. So that's one kind of standardization that is going on. So in the Linux kernel, as well as in the ATF, regarding the message formats. But there's also a question about the actual interaction patterns between attester, relying parties, and verifiers that needs to be somehow codified into protocols, right? And for that, we are working on a bunch of APIs that we want to standardize, both on the attester side with RATSD, as well as on the verifier side with Verizon. So these are public stuff. They have code base attached. They can be used today. But they're necessarily not finished products, but really, I think they have the same ethos that you're looking for. So we are happy to collaborate with you on any of this stuff.
I have another question concerning the attestation. So we speak about attestation, but there are different ways to do an attestation. It could be an attestation of attest the integrity of the software. So you measure the integrity, but there could be other selector that we want to check and get an attestation on different attributes. And for example, you could say, I want to attest that the integrity, so the hash, and it's okay, but we want to attest the fact that it is instantiated in a specific location. How you get this location, this measurement. You can attest also if you want to attest the fact that it has been instantiated by a specific orchestrator. Do you have some input on that? How we can have different selectors for this attestation? Is the procedure and the protocol open to different type of attestation?
I'm not sure I get the last part of the question, but the first one was about how do you attach location, for example, attributes to an attestation, right? And that is
yes. For example, it's one attribute, it's the location, and you want to attach the location.
Yeah, that's very much possible through an endorsement, which we have data formats for that. Corim being the most prominent at the moment. The idea is that you add an endorsed value to that specific attester through an endorsement to the verifier. And you use Corim to convey that kind of information. So that's possible, but that's an example of an attribute that is, metadata that can be sampled from the root of trust, but a trusted, endorser can attach to a specific device or a bunch of devices, whatever. That is absolutely possible using Corim. Okay. The rest of the question I didn't understand exactly, so but happy to continue the conversation if you want.
Yeah, maybe on that point, I would like to just clarify a little bit, Thomas. So when you say that that's a part of Corim, so is there a GPS which is measuring that, or how is that being measured? How are you getting the location actually?
Someone attaches to that information to a specific device.
Who is that someone, and how is that trusted?
Could be you. I trust you.
So it means I'm sitting there. It's not remote attestation. So I'm sitting there and I'm attaching that myself. So that's not remote attestation, right?
What do you mean by it's not remote attestation? It's part of the verification of attestation, right? It is part of the appraisal. It's not remote attestation in the sense that it's not produced by the root of trust of the device, but it's part of the appraisal of remote attestation protocol evidence. Yes.
But who is that entity?
Yes, my question was how you get this location, but a trustable value of this location. So it's coming from a trusted environment, so a root of trust.
I don't know. Maybe.
I don't think that's possible.
I don't think that's possible. You need outside information, right? Like you need an outside non-technical entity attaching the location information to that. That is currently I would say state of the art. You can of course try to figure out some GPS solution, but that has a lot of other technical problems. So I think what Thomas was getting at is like having a trusted entity attach that information to the device, and then a trusted entity to have done that correctly. I think that was what Thomas was hinting.
Yeah.
So I'm going to go and cut in here. I think we're starting a conversation with 2 minutes left here. So I think this can be something if attestation of like location is a topic we need to go into more deeply, we can, or if this is just a conversation that people want to have asynchronously about a specific use case and don't feel that it's here, like either way we can proceed there. But I think we're going to go ahead and wrap up this meeting for this week. Thank you, Henri, for presenting, and for the whole team for showing up. I think we got an introduction to your project. I feel like there's still a lot that you all were looking to learn that we probably didn't get into. If there are specific aspects, if you can try to formulate those and send them to the group, perhaps we can help out there. But logistically, since we're right at the end here, I think we are still scheduled to meet 2 weeks from now. Let me double check that. Yes, on the 3rd. And looking through the list, Jim, would you be able to share that? I think you're next up in the rotation.
Yeah, no problem.
Excellent. And if people have topics they'd like to cover in that meeting, you can add them either directly, I think, into that, perhaps in coordination with Jim, or there's a backlog at the top of the notes document as well. Right now,
can I quickly throw in, there is the Slack channel linked on the website so that you can join the Slack channel to reach us there in case you don't know how to reach us otherwise.
Yes, thank you for pointing that out. In the agenda doc at the top, there is a number of ways to reach the group, including the Slack channel. Okay, thank you all for coming this week, and hope to see most of you next time around.
Yes, thank you.
Thanks, folks. Bye-bye.
Thank you.
Have a good
Bye.
day.
Thank you.
Bye.
Thanks, bye.